So today we are looking at radical operations. Let's take a look at the warm-up for today. We are still looking at simplifying radicals, guys. So you have the square root of 45, the square root of 72, square root of 20, and square root of 150. You're going to go ahead and complete this warm-up on your warm-up sheet. Here is the learning target and success criteria. I'm going to go ahead and blow this up. Make sure that you copy this on your opening and closing sheet. It says we are learning how to do operations with radical expressions. Simplify, add, subtract, and multiply. So those are the operations we should be able to do. And the success criteria is I can simplify radicals, I can add radicals, I can subtract radicals, I can apply product rule, and I can multiply radicals. So these are our learning targets and success criteria. And again, make sure that you copy this down on your opening and closing sheets. All right, so you guys are given a graphic organizer, and I'm going to go through each example for the graphic organizer, and then you guys are expected to complete the classwork, which is a coloring activity. So I'm going to actually have to minimize this and move this over. So the very first thing you should see at the top is square root simplify. I gave you guys two exemplars. So you have the 18. Remember using factor trees, prime factorization to break it down. um Remember that square roots have to have an index of 2. It's understood 2. So anytime you have a square root, there's nothing here, and that number that is actually supposed to be there is a 2. It's understood 2. So anytime you have sets of 2, guys, you should be able to pull them out. What I like to say is they got married. Once they got married and became 1, so they come out as 1. So the example they gave you was 18. We got 6 times 3, and then 6 breaks down to be 2 times 3. They had this group of 3 here, so they pulled the 3 out. And then any individual number, any single number has to go back under the radical. So the answer here was 3 square roots of 2. Square root of 24, they broke it down to be 2 times 12. Remember, you're using factors. And then 12 breaks down to be 2 and 3. And then 2 and 6, I'm sorry. And 6 breaks down to be 2 and 3. And so from here, they circled this set of 2. And what I normally do is underline the numbers that don't, that's single and by itself to remind myself it goes back on the radical. So here, again, the 2 got married and became a union, and 1, they got pulled out. And then the 2 and the 3 got multiplied under this radical. So it's 2 times 3 give you 6. Now let's look at example 1. We have square root of 48. 48 breaks down to be 6 and 8. And then 6 breaks down to be 2 and 3. And then 8 breaks down to be 2 and 4. And then 4 breaks down to be 2 and 2. Okay. So remember, every set of 2, guys, we can pull out. They get married and they get turned into 1. So we have actually 2 sets of 2 that can be grouped and get pulled out. And then we have this 3 that is single by itself. And again, I underline it to remind myself it needs to go back under radical. So for this number 1, we have 2 times 2. So each group gets pulled out. And then under my radical, I will have square root of 3. And from here, you just simplify. So this one is equal to 2 times 2 is just 4, guys. So it'll be 4 square roots of 3. All right, let's look at this next example. We got 3 square roots of 40. The 3, I can't do nothing with it. I would just bring it down. But right now, I will go ahead and break down 40. 40 is going to give me 4 and 10. 4 is going to break down to be 2 and 2. Remember, we're getting them to prime numbers. And then 10 is going to be 2 and 5. So looking at the sets that I have, I only have one set of 2 that I can circle. And then again, the individual numbers or the single numbers, I'm going to underline to remind myself to put it back under the radical. So I'm going to bring this 3 down, guys. I cannot make it disappear. It does not disappear. So I'm bringing it down to remember to use it. So I have 3. I'm pulling this 2 out because here's a set. They got married and became 1. And then under the radical, you'll have 2 times 5 because they single and they can't go nowhere. So they back under the radical. So in this instance, your final answer here for simplifying. And again, if you guys are struggling, please go back and relook at the videos on simplifying radicals. You'll have 3 times 2, which will give you 6. And then 2 times 5, which is 10. So in this case, this answer is 6 square roots of 10. And pause the video at this time if you need to copy this down. Looking at the next section of the graphic organizer, you guys are given exponents. Now this is technically new because we haven't done anything with exponents last semester. All right, so I'm gonna read the rule. It says even exponents divide the exponents by 2. Odd exponents divide the exponent by 2 and leave a variable under the radical and the exponent of 1. Okay, so I'm gonna just give an example that'll make this a little bit easier to understand, but it needs to be a smaller variable because these are too large. All right, so let's look at x to the 6th power. Let's do the square root of x to the 6th. If I write x to the 6th power out in expanded form, I will have 6 x's. So there's 2, there's 4, and then this is 6. Remember that this is still a square root, so I still need 2 groups. That's what this index tells me. I need 2. So looking at the 6 x's, how many groups of 2 do I have, or can I pull out? You got 1 set here. I got 2 sets. I have 3 sets. So this is the same as saying x to the 3rd power. Now, instead of me writing the extended form of this, the easiest way to do it is, again, it says just divide. The easiest way to do this is just say x to the 6th divided by 2, and that's equal to x to the 3rd. Okay? So if the number is even, which is why I say even here, let me highlight that. If the number is even, okay, just divide by 2. So let's look at number 1. Number 1 actually gives us an even number. Our exponent is even. So we actually have x to the 32nd divided by 2. Okay. And because the number is even, you should be able to just divide, and that's what you left with as your answer. So on the calculator, I'm doing 32 divided by 2, and it gives me x is equal to 16. Now, if you want to do the expanded form, you can literally draw 32 x's and then group them sets of 2, and you'll see it's 16 sets. All right. Now, let's look at the rule for if it's odd. It says if it is odd, divide by 2. Okay, so divide by 2, but leave a variable under the radical. Okay, so 40 is an odd number. And again, hopefully everybody agrees with me here. So I can literally say x to the 40th. 41 is an odd number, so I can pull out the 1. My handwriting is sloppy today. Let's try this one more time. X to the 40th, and then I can also do x times 1. So these are equivalent, x to the 40th and x times 1. Remember, it's saying divide this one by 2 because this is the even number, but this x by itself, this one, I would just underline or remind myself, this one's going to go back under the radical. So 40 goes into 2 20 times, so you'll get x to the 20th power, and then under the radical, you'll just get x. And if you want to put the 1 there, you can. So again, the rule says I exponents divide the exponents by 2 and then leave a variable. So if I leave a variable, here's my 1 under the radical, and then I took the rest of 40 and divided by 2. Again, pause the video at this time to write down your solutions. Now we're looking at cube root. Cube root, guys, only difference is the index is 3. And the index being 3 basically tells me I need sets of 3. Okay. And it actually says it on here. It's the same rule as finding square roots, except you're finding pairs or groups of 3. So that's the only difference. The process is the same. The only difference is this little index here tells you that you need 3 things instead of just 2. Okay. So let's look at cube root of 54. Matter of fact, I'll go ahead and do 12. 12 is going to break down to be 3 and 4 since I wrote it up here. And then 12 is not going to work. Let's try a different number. Try a slightly different number. 27. Let's try 27. Okay, so 27. You need 2 factors. That's going to give you 27. We're going to get 3 and 9. And then 9 breaks down to be 3 and 3. So once you have a set or a group of 3, guys, you can pull it out. So in this case, the answer to this one will just be 3. All right, let's look at 54. 54, again, you need factors of 54. 54 is going to give you 6 and 9, or you can use a different combination of numbers, but let's do 6 and 9. 6 is going to give me 2 times 3, and then 9 is going to give me 3 times 3. Now, every group of 3 I can group together, every set of 3, and then any individual numbers that's not a set of 3 will go back under the radical. So for this one, and I'm going to change the color because I'm kind of writing this close. Your answer is actually going to be 3 cube roots. Don't forget your little subscript 3 cube root of 2 for this one. Okay, now we are looking at simplifying cube roots. You're looking at the variable, okay? So I'm going to actually write the expanded form of x to the 12th power. This is the cube root of x to the 12th. So I'm going to write 12x's. So again, let's read the rule. It says divide the exponent by 3. If the exponent is a multiple of 3, then it will be no variable. It will be no variable under the radical. Okay, so if it's divisible by 3 or a multiple of 3, then you won't have anything left. And it says if the exponent is not a multiple of 3, then there will be a variable. So if it's not, it'll be a variable under the cube root, okay, with an exponent of 1 or 2. Exponent will always be 1 or 2. All right, so let's look at x to the 12th power. How many sets of 3 can I take out of x to the 12th power? Let's see, we got one set of 3 here. That's 1. You have another set of 3, that's 2. Another set of 3, that's 3. Another set of 3, that's 4. Okay, so this is the same thing as saying x is equal to 4. Equal x to the 4th power. Or you can just say x to the 12th power divided by 3. Again, it'll give you the same answer, which is x to the 4. So the only difference with cube roots and square roots is square roots you need groups of 2, and cube roots you need groups of 3. And again, pause the video at this time to copy this down in your graphic organizer. Let's take a look at adding, subtracting radicals. So this guy is a brand new, okay? The only way, let's read what it says. It says the radicals have to be the same, okay? And in layman's terms, that means that the radicands have to be the same. So if I drew a radical, doesn't matter what it is, let's put 10 here. We have different parts. The number 10 is considered a radicand. So in order for me to add or subtract any radical, the radicands have to be the same. The number here, the little subscript, that is considered my index. And hopefully everybody agrees that the check mark is the radical symbol. Okay. All right. So if they not the same, and then it says the rule says if it's not the same, then simplify radicals, add, subtract the outside numbers, leave the inside numbers alone. Okay, so these are the rules. The first example, we have the square root of 2 square roots of 3 plus 7 square roots of 3. Well, I wonder why this one let me change the color. I think that's very strange. All right, looking at the radicand, hopefully everybody sees that these radicands are the same. We both have square root of 3. Well, because both of these radicands are the same, that means I can combine my coefficients, which is 2 and 7. So my final answer for this would be 2 plus 7, which is 9. And it'll be square roots of 3. That's the answer. That's it. Example 2, you can go ahead and take a minute to complete problem 2, but it's the same process. Our radicands are the same, so you just combine the coefficients. So here on question 2, we got 8 square roots of 3 minus 11 square roots of 3. I'm highlighting the 3 to show you guys that they are exactly the same. And then I'm going to underline the 8 and the negative 11 to show you that that's what we combining. So in this case, we get 8 minus 11, which my answer will be negative 3 square roots of 3. Okay, so that's it for questions 1 and 2, or examples 1 and 2. And then finally, we have example 3. You have 12 square roots of 6 plus 2 square roots of 54. Now, normally I say, okay, well, the radical is not the same, then there's nothing we can do. But it says, if they're not the same, simplify the radical. Okay. In this case, 54 can be simplified. Okay. And we just literally did this one. 54 give us 9 and 6, or 6 and 9. But then we need to break 6 down, which is 2 and 3. Then we need to break 9 down, which is 3 and 3. Remember, we're looking at square roots. So I have a set of 3 here. And then I have these 2 and 3 that's going back on the radical. Okay. So I didn't do anything to this number over here on the left. Okay. So 12 square roots of 6, I'm just bringing over because I didn't do anything to it. The plus sign didn't do nothing to that. I'm just bringing that over. Okay. But then we have 2. This 2 was already there. I didn't do anything to it. I'm just bringing it back over. But this 3 I can pull out. Okay. Because that was a set. And hopefully everybody agree with that. So this would be 2 times 3. And then finally, under the radical, I have 2 times 3. Or you could just say 6. But I don't want to skip any steps. I'm going to show everything. And I wind up writing 6 anyway. That's funny. Come on, eraser. Okay, so the left-hand side still ain't do nothing with it. I'm bringing the deck down. So we got 12 square roots of 6. And then I have plus 2 times 3, which is 6. And then I have square root of 6. All right, let's look at it again. Our radicands are now the same. We have the square root of 6 and the square root of 6, which means that now we should be able to... For some reason, my drawing tools was freezing. There we go. We should be able to combine the coefficients in front, which is 12 and 6. So 12 plus 6 is going to give me 18. And this would be 18 square roots of 6. Okay. So again, this is how you add and subtract. You can only add or subtract the radicals together if the radicands are the same. Now please write the parts of the radicals down somewhere on your notes. Pause the video at this time to copy this down. All right, finally we have multiplying. So earlier, guys, I skipped over the exponential. It'll say fractional exponents. You can put an X through that because it's no longer our standards. And then also on the right hand side at the bottom, you guys have divide radicals. You can put an X through these too because it's also not our standard. And we don't have to teach this one, so you don't have to do that one. And then we finally have multiplication. I might actually have to add a new slide, so I'm gonna do that anyway, just in case I need more room to write these answers out. All right, so we're multiplying. Let's read the rules. They say multiply the outside to the outside, and then multiply the inside to the inside. So it's pretty straightforward. So on this first one, and I'm gonna try to see if I can fit this all on one slide. We have 2 square roots of 5 times 7 square roots of 3. So first, ask yourself which ones are the outside pieces. So 2 and 7 is the outside. You need to multiply those two together. And then 5 and 3 is the inside. You need to multiply those two pieces together. So in my radical, I have 5 times 3. Okay. So from here, I'm just simplifying. So 2 times 7 is 14. And then 5 times 3 is going to give me square root of 15. So that's it on this one. Always, guys, in math, if you can simplify, please make sure that you do so. If you can simplify, please make sure that you simplify. All right, let's look at number 2. Number 2, we got 6 square root of 2 times 3 square root of 8. Remember, we multiplying the 2 outside numbers together and the 2 inside numbers together. So for number 2, you'll get 6 times 3. And then under radical, you'll get 2 times 8. So 6 times 3 is going to give me 18. And then 2 times 8 is going to give me 16. Now, only problem with number 2, guys, is this actually simplifies. So the square root of 16 is going to give me 4. So this is actually going to be equal to 18 times 4, because this is 4 and 4. So remember, 16 is a perfect square. So on my calculator, I'm literally just typing 18 times 4, and that'll give me my final answer, which is 72. So this one is 72. I can write a little bit neater. And then this number 1 was 14 square roots of 15. I don't know why they didn't let me change them here colors. All right, looking at number 3. Number 3 says 5 square roots of 3 times 2 square roots of 6. So the 2 outside pieces will be the 5 and the 2. And then the 2 inside pieces is going to be the 3 times the 6. So over here, I'll get 5 times 2. And then under the radical, you'll have 3 times 6. So 5 times 2 is going to give you 10. 3 times, that's supposed to be a 6. I don't know why it looks like a 16, but let's fix that. 3 times. I don't know why my pens keep freezing. Okay, 3 times 6. All right, so 5 times 2 give me 10. 3 times 6 will give me 18. 18 can actually be simplified. 3. So you actually have 3 times 6. And then 6 breaks down to be 3 times 2. So you got a group of 3 here. So you'll get 3, because I'm pulling this 3 out, times 10, because the 10 was already there from when I multiplied earlier, and then square root of 2. And again, simplify this. So you'll get 3 times 10 is 30, and then times the square root of 2. That's your final answer for this one. And again, guys, if you write big, I suggest that you write this on a separate sheet of paper, or you can put it at the bottom of your graphic organizer. All right, this is the last one, guys. It says if multiplying to parentheses, then you just distribute. So we're using distributive property. Okay. The easiest way for me to do this, and it's gonna make life a lot easier later because you guys are gonna need this later, is to use the box method. So I'm gonna do the square root of 5. Hold on, let me build a box first. Let's build the box. So we had a square root of 5. I built a 1 by 2 box. Then we had 3 square roots of 7. And then I have square plus the square root of 10. The reason I prefer the box method because it guarantees that you multiply each piece together. So in this case, we get, if it's nothing in front of your radical, guys, it's an understood 1. And hopefully everybody's okay with that. It's an understood 1. So 1 times 3 is 3. And then you're going to do 5 times 7, which is 35. 1 times 1 is 1. I put the plus here because it was already there. And then 5 times 10 is going to give me 50. So I would tell you that this is your final answer, but the square root of 50 can be simplified. So let's take a look at that. And again, guys, I apologize. I am running out of space, but I'm going to try to fit this on here. Square root of 50 is going to give me 5 and 10. And then 10 is going to give me 5 and 2. Okay. So this is a group. Comes out. I'm going to go ahead and switch colors. So my final answer here is going to be 3 square roots of 35 plus this 5 is getting pulled out. Okay. So plus um 5. Oh, they telling me I can't even. That's funny. I can't put numbers on this slide. So let's go back up. They kind of killed my maximum space. All right. So 3 square roots of 35. Why is my ink disappearing? Okay, guys. So I apologize for the lag or the delay. Something went wrong with my PowerPoint. But the final answer for this, you bring it down as 3 square roots of 35 because I didn't do anything with it. And then from here, we simplify. So again, I'm pulling this 5 forward here. So 1 times 5 will give me 5. And then I'm left with just this 2. So 5 square roots of 2. And that'll be the final answer. So for those who might have had questions before, if the radicands are not the same, you cannot combine them. And so you just leave it with the addition or subtraction sign. And so let's take a look at what you guys' classwork is for today. You are, and again, just a reminder, make sure that you put an X to divide radicals because we don't have to teach that in geometry and geometry. The classwork for today, guys, you will have a flower coloring and sock coloring assignment, which focuses on operations with radicals, which is adding, subtracting, simplifying, adding, subtracting, and multiplying. The questions that have division on it, I went ahead and gave you guys a solution. Please make sure that you do the exit ticket for today, and then after that, we will be finished. So great job, guys. If you have any additional questions, please feel free to ask me during class time. Bye.